Hello, so in my recording, I'm going to talk about how unsaturated fatty acids can actually reverse the cellular damage caused by saturated fatty acids. So introduction, lipotoxicity is the accumulation of lipids in non-adipose tissue, which can cause cellular distress. Lipotoxicity has been shown to be a part of the pathogenesis of many different diseases, including diabetes, cardiac failure, and even non-alcoholic fatty liver disease. So let's just begin by saturated fatty acids are the fatty acids that do not have the double bonds, and they are able to clump together and become less fluid, and this can wreak havoc on plasma membranes as they pass through. An example of a saturated fatty acid would be like palmitate. An unsaturated fatty acid, on the other hand, have the double bonds and are not able to clump together, so they do not harm the plasma membrane when they pass through due to their fluidity. And an example of this would be oleate or even alpha-linolenic acid. So it's been shown that that unsaturated fatty acids can actually reverse the cellular damage caused by the saturated fatty acids, and this could even possibly prevent these diseases that lipotoxicity cause. So let's start talking about how the endoplasmic reticulum deals with stress. So when they encounter stress, they go through the stress pathway, which includes the unfolded protein response. And in this, let's just start with GRP78. So under normal conditions, GRP78 is bound to 3 known stress sensor proteins, and these render them inactive. But under stress, GRP78 is actually titrated away from these proteins, leading to many autophosphorylation and homodimerase reactions. One of those include ELF2 alpha phosphorylation, and this inhibits regular ER transcription and actually activates ATF4 transcription, which then activates CHOP. And CHOP actually activates GAD3, which is a growth arrest and DNA damage inducible gene. And so CHOP also suppresses BCL2 and increases the activity of BIM and BAX. And this diagram just shows exactly what I was talking about, but in this diagram, BIP is actually GRP78, and these are the 3 inactive proteins I was talking about under normal conditions, and then under the apoptosis or the stress pathway, you can see the phosphorylation of ELF2 alpha, and you see the CHOP and the ATF4. And you can also see that under survival, the GRP78 is also there. So this first study was done on rat hepatocytes, which, as we know, are liver cells. And this showed that palmitic acid activated the unfolded protein response in endoplasmic reticulum, so as we know is the CHOP and the GRP78. And it was shown that treatment with alpha-linolenic acid actually deactivated the unfolded protein response pathway that the palmitic acid actually activated. So it may be effective in combating lipotoxicity. And the second study was actually done on renal cells, but it showed the exact same thing, how palmitic acid increased the unfolded protein response pathway. But this one also showed how the kidney protects itself by dephosphorylating ELF2 alpha, which would render it inactive, and it wouldn't let it turn off the normal transcription pathway, so you wouldn't even get CHOP. And it also showed that palmiolate, which is actually a monosaturated fat acid, had similar effects of alpha-linoleic acid of turning off the endoplasmic reticulum stress pathway. And this third study was done on pancreatic beta cells, and as we know, pancreatic beta cells deal with the insulin and producing it and storing it. So the palmitic acid actually activated the endoplasmic reticulum stress pathway, and oleate, which is actually an unsaturated fatty, reversed this pathway, so it might be beneficial in the prevention of diabetes if we can prevent the destruction of the beta cells. So implications to practice: by just grasping a better understanding of how saturated and unsaturated fatty acids affect the ER stress pathway, we can apply this to the prevention of many diseases, including the non-alcoholic fatty acid, fatty liver, and kidney disease, and even type 1 diabetes with the beta cells.